Hello, everyone. My name is Mark Baker. I'm the head of big data infrastructure at CSL Behring. So today I'll be going through some of the highlights and challenges we faced implementing our industrial Internet of Things through our multiple global factories. And hopefully I know it's the end of the day, so we'll probably make this pretty quick, unless you guys have a lot of questions. All right. So in case you're not familiar with CSL Behring, we're a global biotech company. And so our global growth over our manufacturing sites has created a sort of asymmetrical blueprint where these sites have grown independently in Germany, Sweden, and the United States over the last 100 years and grown independently. So there's a lot of different manufacturing systems and a lot of different metrics and analytics to collect from each one. So during this presentation, we're going to use a few terms that you may not be familiar with. One is the MES, which is a manufacturing execution system, and that's on the factory floor. That's what tracks each step of the process of creating the drug or the pharmaceutical therapy. And a SCADA system is also a lot like MES system, but it measures time series data from each machine, so a lot more sensor data from each machine. We'll go over the current PACE globalization initiative, which is the business case, which is pushing all of this IIoT technology across the global enterprise, and our partnership with Hortonworks to make this live. So, and then we'll go through a quick QA. So CSL Behring is, I think I went over this a little bit, but we're focused on serving patients' needs using the latest technologies. We're investing in the modernization of all our factories, including creating a gold standard factory in Langenau, Sweden. So let's go ahead. So the last 2 years, really what we've done is create a small POC from using SQL servers and replication from a small fraction from 2 of our manufacturing sites. And using that, so we produce the same drug at both sites. The problem is that one site is much better at yield than the other. So the same amount of raw material goes into both sites, but one site has a much better yield than the other, right? So what we're using is these MES data is to try to say, why is one factory producing a lot more yield than the other, and how can we use that data and spread it across the enterprise to all the other factories? So the success of that proof of concept led us to really expand that to every manufacturing facility and gather as much data as possible from each facility. And during that process, we've also sort of standardized the tools and tool sets that the people at each global manufacturing sites are using to create their metrics and analytics reporting. So as well as each factory sort of growing on its own, so have the tool sets and the analysts have been sort of working on their own to create those reports for the FDA and the European governance bodies. So these are our current locations right now. We have United States, we have Kankakee, Illinois. Germany, we have Marburg. Switzerland, we have Bern. And Australia, we have Melbourne. So these are the places that have historically grown and operate independently. And now with PACE, our global initiative, we are sort of streamlining this and gathering data from all of these sites. So right now you can see the manufacturing analytical silos. So across the world we have the sites I just mentioned. While they were growing, so during each growth period, each site group sort of chose the best of breed MES system. And those MES systems have different backend databases. So some of them have Oracle databases, some of them use Microsoft SQL databases, and they all use different schema and tables to collect the data that they're doing on the MES or tracking that, all right? And also, when they set up these execution systems, they tag each step in the manufacturing process with a text field. And as you can imagine, with different countries, different languages, and these people have just tagged every step with a completely different description. So gathering all that back into a Hadoop framework or a data lake and trying to compare that is very hard without doing some ETL to translate each one into its like for like. And this is our answer to that solution, right? So we've put HDF or NiFi edge servers on the edge of each factory of the MES systems, and connecting them to the MES or SCADA systems and relay that data back in near real time back to King of Prussia, Pennsylvania, where we have consolidated the whole tool set, all the tool sets that all the data scientists are using on top of Zeppelin, RStudio, and S4HANA. So we no longer have analysts writing reports only for their regional site and only on the regional data. We now have analysts all centralized on one Hadoop platform on the data lake and using that, all the data from every site to create the reports. So and as a side note, we've migrated some of our R&D folks over to RStudio and Sparkly R, and they're really excited about using that for their genome testing as well to find new products. We're also looking into adding GPUs to our cluster for their use. So the challenges of getting an IIoT global system going is that, like I mentioned, we have each manufacturing systems using a different back end. We have over 12 different MES and SCADA systems in use. These systems are critical to the day-to-day operation of our factory. So if any MES system goes down, the factory stops and we lose millions of dollars in waste. So during the extraction, we have to be very careful and do impact assessments and make sure that we don't impact these at all. So another problem we're seeing is that historically the network infrastructure hasn't been designed to handle this much traffic back and forth to our core. And so that's also being upgraded right now. So one of the problems we are having is network bandwidth. And of course, we have to encrypt everything on the way through. As I mentioned before, the MES and the text is tagged in different languages. So as it comes back into Hive and HDFS, we have a lot of like umlauts and different things in German and things like that we're transforming on the way. So it doesn't hurt the analytics systems. So we chose NiFi for this, and so really for the flexibility of the custom processors. So each processor is going to need its own Python-based connection to an MES system, since we have different vendors, different backend databases, and different schemas to draw data from. We also want to use a very light touch when we touch these MES systems because they are so sensitive. So we're using the back pressure feature of NiFi so that if there are any network outages back to the core, that when the core comes back up, we don't do a one big pull to catch up from the MES systems. We're also using the encryption and compression methods that NiFi has so that we can reduce our bandwidth usage until the network team can really catch up and up the bandwidth at the sites, and so that we can be in compliance with our security division. We also have the problem of these MES systems having their local time and date for every step they take. So what we're doing is adding a UTC column with NiFi when it comes back into the core so that we can do real-time analytics and see what's happening in real time and compare batch processing between sites. Again, the ETL functionality lets us take care of those umlauts and strange characters that we see. All right, so I know I went through pretty quick, and but look, so I've been through. It's been a long day, and we've been through a lot of conferences, a lot of presentations. So let's look at. I mean, you must have some questions, and you seem like it's an audience that probably knows half the stuff anyway, right? So yeah, let's go ahead.
You were talking about the data that's going over the network. Are you analyzing that data at each site and then only sending what's required?
So right now we don't analyze. So the question is, do we analyze at the site and just send what's required back to the core? So right now we're only extracting what's required and pushing that back to the core. But in the new factory that we're rolling out, is we are going to gather petabytes of data, and that has to send back. And they want real-time alerting at that site. So we are rolling out real-time alerts. Say, hey, one of the centrifuges is vibrating a little bit weird, right? So we can do predictive analytics to say, hey, that's going to need maintenance in the next 20 days probably. So we're working on that type of predictive modeling for some of the machinery.
And I suppose when you have scanners or sensors eventually too, you're going to
Right. Exactly, and we are retrofitting our old factories that don't have those newer machines with some vibration sensors and things like that, so we can detect those and run machine learning algorithms against that data. Yes?
How are you pulling the deltas from the source systems?
So the deltas are being, so each source system is, the question is how are we pulling deltas from the source MES systems. So that really depends on the MES system. So we have 12 different versions of it. So a lot of it's Oracle databases and Microsoft SQL databases, and either we're using a primary key or a date timestamp to get the differentials out of that. Some of them, so one run of a drug is called a lot, and the MES system will create one table per lot. And once that lot's over, create a new table for the next one. So we can write these Python processors or NiFi processors to see, are there any new tables, are there any new lots, and then ingest that lot. So that's part of the custom processors that we're creating for each one of these MES systems. In green.
Yeah, are you committing any of those custom processors back out? Or are they too specific to your system? They're useful.
I think they would be useful. Some of the systems we use are called YAG, OSI Pi, and some of the vendors are pretty huge and used in different facilities. So that would have to be a question for the legal department. I would love to let them go into the open source community, but we'll have to see how that goes. I mean, I think if we pay professional services to help us out and finish some of those, I think we'd probably keep them just because of the financial investment. But we'll have to see. Yes.
I work for General Electric, and they have MES system.
Uh-huh.
Do you know about the MES system?
Yes.
And we try to solve similar problem.
Okay.
And they have one product which is called Data Malt, which calculates the plant efficiency.
The plant what?
efficiency.
Oh, okay.
Yeah.
That's great. So we're doing a lot of trying to do the same thing. So really, I guess in the biotech firm, we're looking for that golden batch, right? So the perfect batch where really our biggest cost is plasma. We pay people for their plasma, and then we fractionate that into therapies for things like hemophilia and things like that. So we have a huge upfront cost on raw materials, and the more yield we get out of that, much more profit we can make. Yes.
How much volume of data are you pulling, and how many nodes or clusters do you have? How many nodes cluster do you have for each site?
So right now we have one NiFi node at each site. It's not HA because we're still in the building out process, but I think we'll be HA soon on the nodes. And we have a 4-node development cluster and a 7-node production cluster for the Hadoop data lake. We have a 4-node NiFi cluster with core for the core, and of course the Embari and Ranger servers on top of that.
Volume of data?
Sorry, the volume data. So it really depends. Right now I'm limiting this to just the MES data, and really it's not that much because we're just in phase 1 and we're just pulling in the same data that we have in our proof of concept, right? So right now we're engaging in getting all the data from all the manufacturing sites. So, but still, the MES system doesn't log a whole lot. So we're probably talking about gigabytes a day. Mm-hmm. Yes?
Are you doing any processing on the edge servers?
So on the edge servers, we are doing some processing. We are trying to get rid of some of the language barriers so that when it gets back to like RStudio or it gets back to Hive, there aren't special characters or different encodings. So we are doing that on the edge, but and we are adding the UTC column to the CSV so we know what time it is. That's a lot harder than it sounds because until recently I didn't realize there's like European daylight savings time and all these different time zones where and they don't stop and start on the same day every year. So we're starting to work that out and translate that to UTC. Yes.
So are you getting any time series information from the SCADA system?
We do. From the SCADA systems, we get a lot of data like temperature, fill rates, things like all of that time series data that comes out of the SCADA systems. Some of our MES systems collect it, and some of our SCADA systems collect it.
Right. So how do you store it? Are you putting in high quality or like a...
Yes. So we store it. So we have a sort of a process where everything goes into a raw CSV format on HDFS, right? It's read-only. And then each data scientist can come in and do their own analytics on it from that read-only into their home directories on HDFS. And I also process it into Hive tables for them.
I see. So these SCADA systems are very proprietary sometimes in nature, right? Like
Yes.
Pi and whatnot. So did you put some Pi integrator or something on top of it, or how did you really integrate with them? I mean,
So to be honest, OSI Pi has been a little bit of a challenge so far. So they're mostly a Microsoft-based company, and I'm using Red Hat to collect data from their historian and the OSI Pi system. So they do require a lot of different kernel changes and updates in only like RHEL 7 and a certain kernel version to get that working.
and then are you trying to condense all this plant data into a single, like, master copies and stuff, because you want to do cross-plant analysis?
Yes, we are. So we take all the time series data from one batch, and we put that in one Hive table. So we do a lot of combinations and things like that so that it's easier on the data scientist to ingest into I can never say it, but Statistica and different tools like that. So we do combine all of this data and do ETL work. Once it gets back on the Hadoop cluster, we use Spark and we use different tools like that to do that ETL work.
Is it a site-to-site protocol that you use from NiFi?
Yes, we are that. And Beck?
Did you mentioned HANA S4?
Yes.
Are you reading from it or are you writing to it?
We're doing both. So in this manufacturing and pharmaceutical environment, we have what we call is GXP and non-GXP. One is it's sort of the FDA and the European unions, you understand what it is, but I guess some people may not, but it's sort of the regulation of how you govern a system, and so the data's, there's checks and balances and a lot more paperwork when it goes into saying the system's GXP, right? And the data doesn't change from source to destination, and it's checked more rigorously, right? So our S/4HANA system's GXP. Our Hadoop system, in order to be more flexible, is non-GXP. So the data scientists can install all kinds of new tools, TensorFlow, and all the cool stuff they're using. And what we do is so we have one record or one system of record for each different data. So what we do is we put all the data into S/4HANA in staging. That's GXP, and all of that graphical lot protocol or that time series data that you're talking about. We put all that in Hadoop, right? And in order not to keep both in both places, we did read and write out of S/4HANA with NiFi. We did look at Vora, but it's just really expensive, and it just seemed, SAP would probably kill me, but it was very expensive, and it just looked like a Spark plugin to me anyway, right? So it's just using Spark on the same level.
So did you write custom processors for S4 or?
Actually, I think there's an open source S/4HANA plugin that we're using. And they have a JDBC driver as well. Yes.
Did the analytics yield any actionable results?
Yes. I don't know if legally I can tell you how much. Okay, yeah. But what I can say is that we're growing very quickly, and funding is not an issue for a lot of these projects, if that's any hint. So, yes.
This initiative, how was your environment? Did you have discrete data marts and silos to move into this, or you had an enterprise data warehouse and you're moving to this?
So prior to this, each manufacturing site had its own enterprise data warehouse, and we're very siloed. And for this PACE globalization effort, we try to break down a lot of those silos. To be honest, I think it's my first time working globally, and if we look at this technology, sure, it doesn't look very hard, right? I'm doing SQL calls, I'm extracting data, right? But socially, it can be extremely hard to deal with all these different siloed industries or siloed parts of the organization, and there's language barriers, cultural barriers, and things like that that you'll run into. So without a big business or like a push, it's very hard to get a lot of people to cooperate. But so far, CSL Behring has been doing a pretty good job at it.
What is your futuristic goal? You want to move the organization away from individual enterprise data warehouses to this, or do you still want to support them in according to?
No, so our global initiative is to combine everything into Hadoop and S4HANA, and as well as all of the business workflows through SAP. So everything's coming into one big workflow. And yes.
Yeah.
Oh, sorry, back.
Can you roughly quantify the efficiency gains you saw when you adopted NiFi?
So before NiFi, we were using some Scoop jobs, but Scoop, in my experience, is sort of like your like best friend and worst enemy, right? So before I worked for CSL Behring, I was a consultant and I was able to take down a Teradata warehouses with just a Scoop job by accident. If you hit a view that had like 5 tables behind it and you didn't realize what you were hitting. So NiFi has a much more light touch than Scoop, where even with 1 mapper or 2 mappers, you can really do some damage to the environment. So with these MES systems, it's very important that I don't ever take them down. Yes. Yes, so with the GXP system, NiFi is going to be GXP, and when it's GXP, I have to do CDC. So we are writing some CDC Spark code to make sure that the tables match once they've been ingested and things like that. So Hadoop is not GXP, so I don't have to worry about any of that data once it reaches Hadoop. But the things that are going into SAP HANA, I do have to do CDC on. Yes?
So you talked about the relational system you're pulling from. So you're using NiFi with some parameterized SQL statements and stuff, because NiFi is not that great with the relational systems, right?
Right. So what we're doing is we're writing custom processes in Python and using sort of of course, the easy ones like put HDFS and list tables and the connection pools with NiFi. But we're using custom processors for each MES system. Just because you're right, it's not great yet at some of this, like looking for a new table every 5 minutes and stuff like that we're trying to do. So those are the things that we are partnering with Hortonworks to try to get around and right. So I can say we've had a great relationship with Hortonworks, and what's been really good about having a global company behind you like that is that, so if there's people in Germany or people in Australia that don't have any idea what Uzi, Scoop, or anything like that is, right? And they think you're talking a completely different language. You can call on Hortonworks and say, hey, look, can you put a couple like pre-sales engineers into the Australia location and have them explain all this for me, right? So, or Germany, and they'll explain it in German, stuff like that. So it's been a huge help. Hortonworks has been a huge help in that way for us. Yes?
How long did this project take, and how big was your team?
You're pretty much looking at the team. Yeah, so I do have a consultant, and we have used Hortonworks Professional Services to augment. So we've had them for about 6 weeks to verify the cluster setup. We also have the globalization process and SAP rollout is contracted to Cognizant. So I do have one Cognizant resource as well. But mostly, yes, it's been myself doing a lot of this rollout. So we're talking, I started in November of last year, so we're making really quick gains at this. But really, it really helps to have a great business driver behind you and the CEO to like really push it through, to be honest. Yes?
You're primarily moving a batch feed in.
Mm-hmm.
The volumes are somewhat kind of but we're playing around a little bit, but what's the like error handling within kind of processors? My kind of understanding is a little bit light on that. How do you
Yeah. So we are, right now we're just looping back to the same processor, to be honest, in NiFi. So we're not doing a whole lot of error handling with that yet. So I think that's on the roadmap, but like I said, we're a little tight on team members. So,
But I mean, you have to custom write that as kind of a liability.
Yes, of course. So that's right now. So the good thing is that as we spoke about, like GXP, and so it's not FDA regulated, the Hadoop system, so that the CDC really doesn't have to be great there yet. So I can kind of fudge that a little until we get everything just perfect. All right. Guess we can go and get an early spot for the refreshments, huh? Sound good? All right. Thanks.